left it at lighting. So now basically we're just going to try and add a few lights in our level. So if you're following along, basically go in your level and try to add, you can add spotlights on the ceiling to simulate a ceiling lamp. You can add point lights around to have a bit more ambient lighting, and then try and build the lights and see the results. And I think right away you would see what I meant by globalization. You see the difference, like before and after. So I'll try and show you guys at the same time. If I go to the level I've just made, so to add a light, you basically go into place mode on the left here, lights category. You can choose any type of light here. Grab a spotlight, put it on the ceiling. You can see that it's kind of doing light, but not that much. I'm gonna put one here. Cool. Once again, I can duplicate lights the same way we duplicate anything by holding Alt, dragging. Right. Can move that around. Okay. I'm not gonna make anything pretty. Just show you guys how this works. Cool. And I can add a point light as well. Just drag it in the middle. You can see that it's making a bit of light. Now, something to remember that's very important. If you select the lights, you can see that by default, they've been set to stationary. And like I was saying, this is not great. So make sure you select all your lights. By the way, to select multiple objects, you select one of them and then you hold down Control key and click your other object. And then that's going to select all the objects. And it sucks. Can't change it. Anyway, forget that. Let's change all the lights back to static. Stationary is not great for performance. Change all that stuff back to static. Cool. And just to show you a bit of properties of the light. So if you go on the details panels on the right, in the light category, this is where you can tweak everything about the light. If you look at my point light, for example, you can see there's like a radius around it. That's how far the light is going to affect things. So I can change the radius here with this property. It's gonna go smaller, bigger. You can also use the scale tool. If you don't want to use the property, you can just scale it. Yeah, and then you can change the color here. Let's say I'm a funky house, so I'm going to that one with orange. You can change the intensity here with the intensity setting. Right? And then the spotlights, one important setting on the spotlight, you see that it has a bit more properties. And there's something called inner cone angle and outer cone angle. The cone angle is basically that thing, these blue lines you see here. That's kind of like the range of that spotlight. So if let's say we wanted to make it wider, make the cone angle bigger, right? And we could also play with the inner cone angle. And you see that it's going to make a second one. And what that means is basically it's creating a fall off between these two cones. So, inside here, inside the dark, the first cone, it's going to be full intensity. And then it's going to slowly go to zero. Right? So this is more or less how you add lights to your level. Something important, I think I've put that down here. By default, the auto exposure is really slow. What the auto exposure is, it's really easy to see. If you go inside in a dark corner and you look at the window, and then you look at a dark corner, you see that it takes a bit of time to adjust brightness, right? Here it's looking fine. Now if I look at the window, it's overexposed. If I look back, it's too dark, and then slowly brightness adjusts, right? So that's a feature of the engine to kind of simulate real cameras. When you're like shooting a video with your smartphone, it's kind of the same thing, right? Looking at the sky, and then you turn around, look at something dark, it takes a little bit of time to adjust. But when we're editing, it's kind of annoying. So to go around that, you can add something called post-process volume. Don't worry too much about what this means yet, but if you go to the edit place mode window, click on volume, and scroll down to post-process volume. Just add one here, doesn't matter where. And then there's quite a lot of options. You don't need to worry about all of them right now. All you need to do right now is scroll down to the post-process volume settings category. It's just going to enable that infinite extent. What this means is that if you don't tick that, the post-process volume will only trigger when the camera is inside it, right? If I'm outside, it's not going to. If you tick that box, it means it's always active. It doesn't matter if you're inside or outside. Now that we've done that, you can scroll back up, go to the lens section. There's an exposure category. Open that up and just change speed up, speed down to be like 10. You see that now when I look at the dark corner, it's way quicker to adjust the brightness. Right? So that's just something to remember. If it's especially if you've made quite a dark room with no window, it's going to be pretty annoying every time you look around. It takes so long. That's just a little tip to it. So now that we've added our lights, one thing we need to do is build the lighting, because it's not very obvious now, but the lighting right now is not extremely accurate. It's kind of like a preview mode. It's not taking into account all the bounce and global illumination. So if we just hit the build button at the top here, you see that a few things are going to happen. So starts building a texture and then starting a swarm. Don't worry too much about that error. It was a bit fast because it's not much to build. But you can see at the bottom right of my screen here, there's that little icon. It's a swarm agent. Double click that. That's the swarm window. Here our lighting build was pretty fast. But if you have a big level with a lot of meshes and a lot of lights, it's going to take like a few minutes. So this window will tell you how long it's taking, and if you set it up, distribute the work into multiple. So that's done, and you can see now that the lighting is completely different. Right? It's darker, it's extremely low resolution. But the important part is that now at least I'm getting accurate shadowing and light bounce. So the light bouncing is basically, you can see that if I click on my blue spotlight, it's only supposed to affect this part here, right? But somehow I'm getting a bit of blue kind of everywhere. You can see it also on that light here, on the yellow one. The radius is only here, but somehow once the exposure adjusts, there is a little bit on that wall of yellow kind of bleeding out. And that's what I see here, you see well. That's what I meant by global illumination, by bounce lighting. That's when the light basically comes from here and then goes in this direction, hits the wall, bounces, hits that wall. That's what we call global illumination. So yeah, that's basically how you add lights and build static lighting. And yeah, something to but all that's all been built into a texture, and that texture has been applied to all my meshes. So basically now the light almost doesn't exist anymore, because all the information has been recorded in that texture, which means when I run the game, it costs 0 because it's just a texture now. No, the lecture is not recorded, sadly. Probably should have. All right, moving on. Any question about lighting?
Just real quick because I
Yeah.
missed it. How did you make it so that the light was only pointing in a certain direction again?
So for the light to only point a certain direction, um, that's because I'm using a spotlight. So you see when you light category here, you can choose a point light, which is that one, which has the
Ah, I
kind of
see. Yeah, yeah.
omnidirection one, and then spotlight is like a shape like a cone, so it's only hitting one kind of angle. Make sense?
Yeah, and then the other thing was you somehow did something to change the resolution of the light texture that was applied.
No. I mean, I built the
Okay.
lighting by clicking the build button on the top, and that basically calculated all the static lighting and basically kind of stored all the lighting information into one big texture for the level, and that applied it to every single.
Okay.
Right. So until now, the lighting we were seeing was like some kind of preview, and it was still being kind of like dynamic because it was trying to preview what the lighting would look like. But now we've actually built it, actually stored all the lighting information inside the texture and applied that to the mesh. So now we're actually seeing the final result. Of our lighting. Make sense?
This is again mostly the artist's stuff to do, isn't it? When they do.
Yes, but I think it's important for programmers to know because if I'm an artist and I don't know much, I'm start adding lights around everywhere. Oh yeah, light, 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 light. You can see what happens now. There's like a bunch of red crosses, and there's a reason for that. It's because you see that light by default is set to stationary, and as we talked about, stationary is hybrid between static and dynamic, which means you can see these three lights here are overlapping. Their radius, you see the circles, are all overlapping, and that's a hardware limitation. You cannot have that many dynamic lights, but artists wouldn't know, right? So I think it's important for you guys to also know how to set up, how to properly set up the lighting for like a level, because you need to set up most of your lights as static, not stationary, and then only set the lights that need to be dynamic as either stationary. And you also need to know how to how to bake the lighting, so how to store all the static lighting information inside the texture so it's applied. That's basically what we've done by hitting the build button, right? So yeah, it's art stuff, and you guys probably won't be placing the lights or making them a certain color or whatever. So the technical constraints and also the impact that the bad setup can have on your performance. Does that
I
make
guess
sense?
it is a pretty important aspect of like game design, particularly if you're doing something that relies on lighting, like horror.
Yeah, yeah, it's true because like if if you start going, oh, I'm gonna make a game that has um, time of day and has real time weather and stuff like that, and real time night and day cycles, then that means your game is probably going to be using mostly dynamic lighting. And so right away, that means that game is going to have a big performance hit. You're going to have to take a lot of stuff into consideration when you design your game to make up for that performance hit just because of that choice, right?
And the other thing is, you know how there's dynamic lighting can't overlap itself, right? Like you can't have more than one source of dynamic lighting in the same radius.
Yeah,
So
yeah,
just and this might be a little bit more technical than where we're at now, so just say so if it is. But like, surely you would have like a dynamic lighting that casts a shadow for the player that's like the sun source, so directional dynamic lighting, and then you might also have like different sources of light inside a room that could cast shadows as well.
yeah.
So how does that work if you can't have dynamic lighting overlapping itself?
So it is a bit more complicated. It's actually you cannot have more than three stationary lights. You see that? So let's say four, and it goes like nope. But if you set them to movable, which is full dynamic. You see that now it's fine. So it's a limitation because stationary is a hybrid between static and dynamic. It's actually using specific type of shadowing. And I think it's probably a bit too advanced for right now, but
Right.
it's because, you know, when you go full movable, then you're basically using the functionality of the deferred rendering. You know what that means. If you don't know, don't worry too much about it. I think that's a bit too advanced for now, but it's pretty safe to assume that, you know, going too crazy on dynamic lighting is not the idea for performance.
Hey, Chris, just a question.
Yeah.
With the dynamic lighting, for example, like if your player character is holding a torch, is it possible to use a dynamic light for that?
Yes.
Okay, so if we were to add a dynamic light to a player, how would we go about doing that?
Like if I was to show you, that would take quite a lot of time, I think. So I can't really show you now, but it's not extremely complicated. You would set up an actor for the torch, and you would actually attach the dynamic light to the torch, right? And that's the easy part. Now, attaching the torch to your player, that's what takes a little bit more time. It's not complicated, but I think it would take a bit too long for me to show you. But it's definitely feasible and pretty easy.
So it is possible for us to do.
Yeah, definitely.
Sweet, that's all I want to know. Thank you.
I'm not sure I understand. They changed the speed just. Not sure what you mean by speed. Oh, the exposure, right? Yes, so I added a volume here called post-process volume. This one. So I drag and drop it. We just delete the old one. So I drag drop it here. I've got this post-process volume. And the first thing you need to change, if you scroll down the bottom, post-process volume setting. By the way, you can also search here details. You can search for any setting. So right now, if I search for infinite, I can find the setting. So seek infinite extent so that it is always active, no matter if you're. So that's basically just when you're talking about the speed of brightness, which actually is called exposure. You'll find it in the lens. Basically, just tick these two boxes, speed up and change the value to something like 10, and that will just make it seem much faster to adjust the exposure. That's how you do it. Ryan, there's a PowerPoint. I'll share it after the lecture, unless you really need it right now. I'll move on because there's actually quite a lot left. All right, so we've added lights. All right. Yeah, if you don't mind just following along from here, and then I'll send you the PDF. So moving on to content management. We're going to look at the content browser, which is basically where you manage all your content. This is where you can create new assets. This is where you can import assets. You can browse existing assets, and you can manage, like, delete, move, duplicate any kind of assets. So it's pretty straightforward. On the left, you have a folder view that shows you every folder that you have. Over here, that's the asset view, and it gives you all your thumbnails of your assets, whether it's a mesh, texture, material, sound, anything. Will appear. Window. The view options on the right allow you to kind of filter or include different type of content. You don't need to worry too much about it right now because most of this is automatic. And then on the number four, that's your filter window. And this is where you can filter by type of assets. So you can say, oh, I only want to see meshes. You can click here, static mesh. Or I only want to see textures. Filter by textures. To create a new asset, once again, it's exactly the same way we've created a level. You can just click the Add New button, select which type of asset you create, or you can right-click content browser in an empty space, the same menu. But to import assets, basically just click the Import button, and that will pop up a window that will ask you to load whatever file you want to import, and the amount of files supported is huge. You know, it supports any kind of format from any 3D software. It can support Photoshop file, textures, JPEG, whatever, any kind of sound file. You can more or less import anything. And then to use content, probably already done that. But if you want to place an actor, whether it's a mesh or anything, you can just drag and drop it from the content browser into the viewport. Also important to know that within the content browser, you can reorganize all your content. You don't need to go through your like Windows OS kind of Explorer to reorganize things. It's actually not recommended because it probably mess things up. So if you need to reorganize your content, do it from within Unreal. And you can basically drag and drop folders to them or copy them. You can drag and drop an asset into a different folder or copy it. Everything is doable from here, but definitely do it from within Unreal. Don't do it from outside of Unreal because it might create. Yeah, let's see if we can do that. So try and reorganize your projects, and create a new folder, call it levels, and then move the level that you've created to that levels folder. All of that can be simply done by using drag and drop. And then what I'd like you guys to do is also add starter content if you haven't already when you've created the project. So you should have done it when we created the project, but if you haven't, please do it now. I'll show you how that's done. So basically, just to show how the levels folder is done, you just create a new folder, you just right click somewhere and select new folder. Here I've made a new one called levels. And I just want to move the one we've created here into the levels folder. So I'm just gonna grab it, drag it into folders. You see it's asking me if I want to move or copy. Say move, and it's moved it for me. Now it's in the levels folder. Problem. It's pretty easy. For the starter content, I already have it here. But if you don't have it, like you forgot to add it when you created the project, all you need to do is click the Add New button here, and then you pick Add Feature or Content Pack top, and then go to the last tab, Content Pack, and select Starter Content, and then Add to Project. When you do that, we'll load for a little bit and create a folder here called Starter Content. We'll do that now because we're going to be using it in the next section. All right, moving along to materials. So this is one of these features that you think may only be for artists because that's how they're going to make things pretty. But it's actually pretty important for you guys to know at least the basic concepts, because once again, there could be quite a lot of performance impact from a complicated material. I think you guys also need to know how to create an efficient process for creating materials. And that's going to be done by using something called material instances. That right now. So first, what's a material? If you've been using Unity, for example, they call it a shader. Other softwares, it's called a lot of things, but basically, it's the definition of how a surface on mesh is supposed to look like and how it's supposed to react to light. So anything from like surface properties, like how shiny a surface can be, how rough it is, does it have bumps, is it metallic, does it emit light by itself, all this kind of stuff. And in Unreal, it's using something called physically based rendering, which means that it's trying to replicate real life physics of lighting. When I say physics, I don't mean collision, the actual way that light works in real life. So it's doing that by using more relevant values like roughness, metallic, things like that, rather than in old engine they had kind of fake values. But yeah, so some essential concepts that I think is important to understand. Like I was saying, it's using physically based rendering, so it's trying to replicate the actual real life science. Um, so like this is, you can see it in here. There's the base color, sure, but it's also the amount of the roughness means how kind of like shiny or not. Normal is like bumps on the surface, stuff like that. Now, this is the important part. I really like you guys to. Is the difference between a material instance. So if you use Unity, it's basically the. Okay, I don't want to confuse you. If you use Unity, ask me later and I can tell you, but I don't want to confuse people right now. So a material is basically, at the end of the day, a material is code. And you can see here in that little window, it's showing you the code for that specific material. It's a code. It's a HLSL shader code. It's a shader, right? So even though it looks like a bunch of nodes connected by wires, at the end of the day, it's a bunch of shader code. And that's what we call in Unreal material. But there's also something called material instance. And a material instance is, I don't know how else to explain it rather than instance of a material. So we have a material that has code, and then we've made instance of that material. So the instance does not contain any code. The instance just tries to override, like change a few parameters from that material, but it doesn't change the code. It just changes a few variables, right? And that's important because the material is code. If you change anything in the code, you have to recompile, right? You have to recompile the code. It takes forever, and it's going to also recompile any other material that has a dependency on this material. So this is where you can waste a lot of time. But if you create a material instance, because the instance is not code, it's just a bunch of variables that you're changing. You can change any of that, and you don't have to recompile anything. You can get real-time results. Change stuff. So that's the important part. If you're gonna work on a game with, artists, because sometimes artists don't know about instances, they're going to create like thousands of materials, and they're gonna make a different material for, like, one material for each object, which means you're gonna have like code everywhere that does the same thing, and it's not very efficient, right? So one of the recommended way, like efficient way to do it, is to create what we call a master material. So like, one big shader that decides how most of the things in the game will look. And then you can have a bunch of parameters, so a bunch of variables that you expose, and then you can edit instances. And then when artists make different meshes, instead of creating a new material, instead of creating new code, they're going to reuse what's in the master material by making an instance and basically just setting a bunch of parameters. And that's going to save so much time. So much time. Like, I cannot emphasize this enough. If you don't work with instances, basically going to see the editor pop up every 5 minutes with like 30,000 shaders to recompile. It's going to be recompiling. So it's very important to try to set up a workflow with instances. Any question on that? That's a pretty important concept. All right, sweet. So the material editor is basically a visual representation of shader code. right? Here, we're basically trying to have, some kind of visual scripting version of our shader code. We have a bunch of nodes. Some of them have parameters, some of them have textures, and all these nodes are kind of like output here in this block, which at the end of the day is our. So how the editor works, you have a preview viewport here where you can see the result of your shader. The details panel on the bottom left, that's your usual details panel with properties for the selected object. Here, that's what we call the node graph. So the node graph is like a representation of the code with some kind of visual scripting, visual node graph representation. And then you have the toolbar at the top. That's your usual toolbar to apply a few other options. I'll be advanced for now. And the five on the right is your node palette. So this lists every single nodes available for the graph. So a node is like a box, right? So this lists every single kind of actions that you can have in the shader. Really, in terms of code, that translates to what kind of functions are available. So yeah, when it comes down to graph itself, there's a few things to remember. So the most important part is that big square here, that number one. That's what we call the base material node, and that's the final output of the graph. So whatever you create on the left, whatever your kind of code might be, needs to output something into this node because that's the final result of it. It's a few different kind of nodes. I'm just gonna go quickly. You don't need to remember like the details of that because you probably won't be creating shaders like artists would be, but I think it's still important for you guys to understand how a shader works, because if you have to optimize or debug a shader at some point to understand what's going on. So different types of nodes. This one here is what we call a constant. This is a value that never changes, right? It's not a variable, it's a constant. Here it's going to be 0.8 forever. No one can change that. Number three, here, this is basically the same number. Sorry, it's the same type as that constant, except we've made it a parameter. So now it's a variable, which means if I create an instance from the material, then you can tweak this number, tweak that normal intensity, any kind of number. So far, I've only shown you what we call a float one. So it's a parameter with one number right now. It's only one. If you look at number 4, this is what we call a color node. You can see that it has a bunch of outputs. Right? It's like a, sorry, let's look at the texture sample instead. You can see it's got the RGB output over here. But really, what a texture sample is 4 different kind of outputs. It's got an R, it's got a G, B, and an A. At the end of the day, it's just 4 numbers. So you see how that number 2 here was only one number. We call that a float 1. This guy over here has 1, 2, 3, 4. It's a float 4. So it's a node that has 4 kind of, and that's how we define a color material with 4 numbers: the amount of red, the amount of green, blue, and the amount of alpha. Alpha being the transparency. The node at the top, the white one, is basically all of them together. So the data going through that wire here is actually going to be 4 numbers. These 4. So that was a color parameter node. It's also a parameter, right? So if we make an instance, we can change that color without having to compile the shader. And then, yeah, you have the texture sample node, which, yes, output 4 numbers as well, but the input, as you can see, is an actual texture file. So here I've got this kind of weird brick wall texture. You notice that this one is not a parameter. It's a constant texture sample, so it cannot be changed in the instance. But if I wanted, I could convert this to a parameter. I can just right click on it, and there will be an option called convert to parameter that will convert this to a parameter. And the instances override could change that texture without having to recompile all the code. And then there's a bunch of other kind of different nodes. You can do basic operations like multiply or pair, this kind of stuff. Here we have a multiply that you can see takes a float 3 node, so like RGB, and multiplies it with a float 1 and outputs that in. So this might be a bit advanced right now, like this might be a bit overwhelming. Don't worry about it too much. What's important is the basic concept of how this works. You have this base material node here, and whatever setup is happening there basically outputs everything into one of these connectors to define how the shader looks. So yeah, back to material instances. Like I was saying, materials are just, and when you change it, it recompiles everything. It takes quite a lot of time when you're trying to iterate, figure out the look of material. It's going to compile all the time. So I did mention that a little bit, but the recommended workflow for any project is that you create master materials, which will define, the overall look of most objects. Like, a lot of projects will make a master material for props. So any kind of furniture, any kind of world object will have the same master shader that will define, okay, it can have a normal map, color, it can have parameter for how shiny it is, it can have another parameter much metallic amount is in there, and then you will make a material instance for basically any object. So let's say I make a new object like a table. I can just make a new instance of my master material and call that shader, table material instance, and I would just change the texture, change how shiny it is, and put that on my mesh. And I don't need to recompile any code. I don't need to change any code. So that's really the one thing to remember is that workflow, material and material instance. There's a link here at the bottom, YouTube series by Epic, which is really interesting. I recommend checking it out if you have free time at some point. So now let's try that. Let's jump in engine and see if we can make a little material to make our walls look a little bit less gray. So we're going to create a new material and create a few parameters we can tweak in our instance. We're going to make an instance, customize that. We're actually going to make several different instances so we can have different looks and so you will need the starter content because that's what the textures are. So if you don't have it, please add it like I showed you in this part. So let's try and do that. I'm going to go here in content. I'm just going to make a new folder, materials. So to create a new material, once again, you just right click your material. Try to respect the naming convention. In Unreal, it's kind of important. So when you make a material, go like M underscore and then the name of your material. So this is going to be my master material. Cool. And then I can double click to start editing it. So what do we need? We just need a few parameters, right? We need a texture for our base color. So how do we add a new node? The palette and search for texture. You see there's quite a lot of them. Really what we double check. Just give me a second. Texture sample. So if you look for texture sample here, you can just drag and drop this. You can also, there's a keyboard shortcut. If you hold down T and press and click, so that's going to create one. So anyway, we have a texture sample, but remember we want this to be a parameter, so we tweak it in instance. So if you just right click on it, you can see there's a convert to parameter. So go ahead and click that. You see that now it becomes a parameter. Let's give it a name, call that the color texture. And I'm going to connect the RGB base color. Give me an error because I haven't set a texture. That's fine. Just go in here and add any texture. It doesn't matter for now because we change it in the instance. Right? So you can see that now it's updated to grayish. I'm also going to make a new parameter for roughness because I want to be able to control how shiny that surface is going to be, right? So if I look in here, the right side, constant, you can see that the first option is what I want. I want a constant 1 because it's just one value, right? You just want something between 0 and 1. And I'm going to connect that to roughness. Once again, I want this to be a parameter, so I can just right click on it and say go to parameter, and then name that, say, roughness. And you can give it a, see the default value is 0, it's not rough, which means it's very shiny. You can see here. Cool, so we've made a roughness, and for now I think that's all we need. If you want, you can play around and test out all different outputs and see what they do. But because we're kind of running out of time, I'm just going to try and go through it. So now I'm going to save it. And now this is where the fun kind of begins. If I right click on that master material created, I can select create material instance, right? And it's giving me a name that I don't like because I like to go by the naming convention. So I'm going to go mi underscore. And this is going to be my floor material. I'm naming it mi because that's a material instance. And now I can just, sorry. Now you can open the material instance by just double clicking on it. Cool. And you can see that this is a bit different from the material editor. There's no graph anywhere, right? And this is because we're not changing any code. We're just changing a few variables. So first, I don't like how shiny it is. It's a floor. So I'm going to change the roughness to, let's say, 5-ish. Let's make it real value. And I also want to change the texture. So I click that. So just a quick, that box here, when you tick it, it means that you're changing the variable. If you untick it, it means just use the default value. So that this means overriding or not overriding. Here I'm overriding it 0.5. Now I want to override the texture. Change it to. So when you use that drop down here, you can search any texture that are in the project. So you can search for floor, and then whatever floor, walnut. Now I kind of have some kind of floor. By the way, when you're searching, if you don't see anything, you might just have to go view options and tick that show engine. But now I have my walnut floor. It doesn't look too bad. So I'm going to save that. And what do I do now? I want to apply this to all the brush, right? How do we do this? Just drag and drop. Okay. You might have to compile at some point. But you can see that now I've got this kind of floor. Yeah, that's not too bad. Because I'm lazy, I'm also going to put it on the seating. Sweet. So you see how we've created a floor based on a shader, right? We didn't change any code for that floor, which means that now I want to create one for the walls. And once again, I don't want to redo all that code. So all I need to do is either go here and say create material instance, or you can also just duplicate that floor. And that's still going to work because this is still an instance of master material. And you can actually verify that by opening it. And in the setting here, you see there's something called parent. It's pointing to master material, which means that my material instance here is still an instance of master material. So duplicating is also a valid way to create an instance. So now I'm just going to rename that to mi wall. Cool. And I'm going to, for wall texture, there isn't, sucks, rock. Yep. Rock slate. Just use whatever texture you want. I have to use the same one. Anyway, I don't want it shiny at all. That's like a rock. So Save that. And that's it. You just drag and drop any wall that you want. And, there you go. Now we've, oh yeah. So a note on geometry brushes. Because remember, this is editable geometry. It still considers that geometry as a per face kind of geometry. So when you drag and drop, it's only going to put it on the face that's under the cursor, which yes is a bit annoying, but if you want to set the whole object to one material, just select it, go in the details. You can see there's a surface materials property. You can just here either search through here, that's a bit annoying, or you can just drag and drop from the content browser directly into the property. Work. Well, that's a fail. All right. Okay, so it's a bit annoying, but you actually need to select every single face of that geometry, because that property you see here is actually the material for the selected face. Yes, it's annoying, but there is a quick shortcut you can use. So if you select the brush and go Shift plus B, Shift B, you see that it selects all the faces. And then I can go here, surface materials. You might have that weird display 2 materials thing, just click on it. And now you can actually drag and drop. Now it's gonna set them. All right, so that's a bit. So there you go. That what we've done now is that we've created one material, and that's one piece of code, and we'll be using it for every single surface that by creating instances. And each of our instances has a completely different look, but we haven't changed any code so because we're using them. So that's probably the one important thing I'd like you guys to remember materials is that workflow between material and material instance, because that's gonna save you quite a lot of time. So yeah, that's it. Is there any question about materials? No?
None for me. No.
Yeah, actually, I'm sorry. Where did you find the thing for the roughness again? I think I just missed it.
So in your master material, node graph, I've connected a parameter to the roughness output. Right? So if you've done that in your material, and when you look in your instance, there should be a roughness or whatever name you've given to your parameter appear here, and then you can tweak that.
How do you add the parameter? Sorry.
So you go back in the material. You need to connect something to this, right? So you can constant. If you search on the right, search for constant, or you can also just hold the 1 key on your keyboard and then click. That's going to add a constant. Another cool shortcut is you can hold, I think, the C. Okay, I forgot the one. Sorry, just a sec. Oh, yeah, it's just going to. Anyway, just add a constant either by holding 1 key and clicking, or by looking for constant here and drag and dropping it. Right? Once you have that constant, you can right click on it and convert it to a parameter. And then you give it any name you want, right? Connect it to roughness. Then you save. Remember to save because it's not going to appear. And then go to your instance, and now it should appear here. You can see I have that param that just showed up. I can tweak it. Does that work?
Yeah, thank you.
Hey, just one more thing. For the master material,
yeah.
What's the blue piece of code connected to it?
So if you
Because like the blue piece of code, if you go to the master material,
yeah.
The blue box, the blue square on the left side.
This
the
thing?
color texture, yeah.
Yeah.
When I try to right click, it does not even show for me.
Okay. If you right click and look for texture, you're looking for texture sample. It's this one
Texture
here.
sample. Okay.
But you can also just directly add a texture sample parameter 2D. And I show you the difference. So texture sample parameter 2D, texture that's already a parameter. But if you look for just texture sample, it's a texture, but it's not a parameter, right? That's a constant. Can you see the difference?
Yeah.
Right. So you could directly add parameter if you want. I've just been showing how to convert them, but you don't need to convert. You add directly texture parameter, and then connect the RGB base code.
Sweet. Thank you.
Yeah. Good. All right. So now we're gonna move on to landscapes. So someone was asking me about making fields, and I believe that's what you were talking about. In Unreal, it's called terrain or landscape, and it's a feature by itself. And the reason it's not made as just a mesh that someone made, Max or Maya, imported, is that the landscape is gigantic, right? If someone was to build this in Max or Maya, it would have millions and millions of triangles, vertices, right? If you don't know what a vertex or triangle is, if you look at that picture at the bottom right, it shows you that this landscape here is actually made of like a bunch of squares, a bunch of triangles. And in a game engine, the more triangles you have, the heavier on performance because the graphics card has to process all these triangles, right? And so traditionally in games, very old games, when we had a landscape like this, wasn't even a thing a few years ago, but this would be made as like a one big mesh done in Maya or Max, by an artist who would make like a gigantic object. But it wouldn't be very efficient because it would be either too heavy or the artist would have to go so low resolution that it would look like crap. And that's why now we rely on that thing called landscape, because it allows you to create a very, very big, I'm talking like thousands of kilometers terrain that's automatically optimized based on the distance from the camera. And that's awesome, because if you look at the picture at the bottom here, you can see that the closer we are to the camera, so the bottom part, has much more details, much more triangles than the part that's far away, right? So the further away we go from the camera, the lower resolution our landscape becomes. And that's the whole point about this feature, is that it kind of manages the landscape for you automatically. It also has some pretty sweet material kind of like functions where you could tell them the landscape that, if you have a slope that's higher than, let's say, 40 degrees, then there can be no grass. It can only be rocks, right? And so you see later on there's a tool for painting texture where you can set a rule in your material, and then when you're painting, it will automatically look at the slope and put grass where it's flat, and rock where it's slopey, and stuff like that. Or you could tell it that you want snow to start appearing when it's high enough, or all these kind of things. So there's quite a lot of features. We're just gonna look at the very basics because we're running out of time, and honestly, just landscape could take a whole lecture by itself. But once again, I think it's important for you guys to at least know the basics, so if you have to deal with it at some point, you know what to do. So it all starts with the landscape tools. So if you remember the modes panel here, it's the icon that looks like a mountain. You can also access it by Shift and 3. And it's got 3 different modes. It's got manage, scope, paint. So manage is basically when you create a new landscape. There's a bunch of settings. I'm not going to go over the settings too much right now. Just keep in mind when you create one that the default settings are usually the ideal ones because they've been optimized. Sorry. But overall, you have to be careful because if someone seeks, sorry. Right now, this lecture is about the high level, just the basic concepts, and then next week we're gonna look at blueprints, basics of blueprints, at least to get you started on making stuff. But then as we go along, we will probably start doing a few workshops if we see that there are some topics that you guys are either interested in or that you need to make your project. Then we do workshops on specific aspect of it. But it's all depending on the time we have. Anyway, yeah, remember that all these settings here will affect the overall complexity and resolution of the landscape. So you have to be pretty careful with that. And so, if you're working with artists and there's some weird performance hit somewhere, you might want to look at the settings they've used when they created the landscape, because if I'm an artist and I don't really know it, I would probably take all these settings and set them to max. And of course, everything is super. Yeah, you can whatever you need. It's fine. Yes, that's the manage tab. You can also import. Maybe some artists prefer to do that. You can import a height map, which is basically the information of the terrain stored in a black and white picture that they could have created in another software. You can import it from here, and it will convert it into. The sculpt tab is basically how you sculpt the terrain, basically, how you make it, raise it, you lower it, create cliffs, slopes. Yeah. And the paint tab is to basically paint layers of materials on your landscape. Note that it does require a specific setup in your material code, in your material shader node graph. But I probably don't have time to go through it today, so take a look at this link here, because this will explain how to create setups so you can have layers like in this screenshot here, be able to select when you paint, so you can paint different kind of things on your terrain. Right now in the example we're going to look at, we're just going to have one layer, we're just going to have one material, it's just going to be grass. But if you want to have something more complex, take a look at this link here. Yes, it's edit landscape. Basically go to the scope. You have a few settings you can play with, like the strength and basically just left click anywhere in the viewport and it's going to start raising the landscape. You can also shift click to lower the landscape, and that's basically it, really. Like, it's pretty straightforward. You're just painting stuff. And play around with the different tool in here. You can click here on sculpt. There's a bunch of other ones like smooth or flatten. Flatten is pretty useful to create clips and like a Nintendo 64 kind of game. Smooth it out. The painting tab is where you're going to start painting visuals, painting material. In this screenshot, they've actually set up the material to have several layers. So once again, if you want that, take a look at the link. But we're only going to use one, and we're just going to put some grass on it. So painting is the same, works the same as sculpt. Select the paint tool, left click somewhere, it's going to start painting. It's basically just like Photoshop. You just start painting around, and then shift click, you start erasing the current layer. Let's try it. Let's do it. So what we're going to do is we're going to create a new landscape. We're going to make it look like our house is on some kind of terrain. And then we're going to assign a grass material to the landscape. All right. Let's try that. So I'll go in engine. Yeah, we have a house right now. It's kind of floating, which sucks. So to create a new landscape, remember we go to the landscape tab here, or you can hit Shift 3. It's going to switch to landscape. You can see there's like a weird green grid that appears. This kind of shows you a preview of how big your landscape is. So the default settings shows you a landscape that is going to, if I switch to top view, you see it's pretty gigantic. Right? By the way, when you're in the top view, you can use the measure tool to measure distances. So if I go and I hold the middle mouse button, oh, I've got a new mouse. Sorry, I haven't set up my mouse. Anyway, if you do it, you should be able to drag the middle mouse button, and there's going to be a line coming up that would show you the distance. But I'm pretty sure that now they should. Oh, it doesn't work on the landscape. But basically, it's about 25 meters one side, so 50-meter wide. So yeah, let's create that. Hit the create button. Just leave the settings on default for now. You might want to put in the material here, look for like grass. And you see there's a ground grass material. Just assign this so we have some kind of visual. Actually, sorry. Actually, just put nothing. Then we're going to look at how to. If you've already put grass, don't worry, it's not big. So yeah, leave everything to default and then just click create. Don't click fill world because that would fill the entire world. And because our world has not been set up yet, it's going to be 10,000 kilometers. So yeah, don't click that. Just click create. All right, you can see that it's created. The reason it's gray because we don't have any material yet, right? Okay. So first problem is that it's in the middle of a house, right? So I want to lower the terrain so it's not going to the building. How do we do that? So you go to the scope tool here. You select the scope tool. It's a bit big right now, so you can change the brush size, reduce that. And remember to lower terrain, you're just going to go shift and click. You see now it's going down. Right? It doesn't need to be super precise. It's a good time to show you the flatten tool. So if you click on and select flatten, this tool basically, once you hold it, will keep the terrain at the same height as when you started. So I'll show you. If I start here and hold, now everything's been flattened at that height. So now I have like a nice ground that started. Cool. And then now you can basically play around, do whatever kind of shape you want. That's all up to you. I'm gonna do a quick one here. Go back to sculpt. I'm gonna go back to a bigger brush, and I'm just gonna try and do like it's gonna be pretty ugly. Just start sculpting some stuff. So yeah, now we have your house out of nowhere. You can see that here it looks a bit weird. It looks a bit weird over here. So I want to smooth that up so it looks a bit less weird. So I can use the smooth tool right here. Smooth, you basically just hold the left mouse button and it's going to smooth things. So now it's my house again. You can undo at any time with Control Z. So when you smooth, be careful. Use a smaller brush and try not to hit the house. Acceptable. But anyway, it doesn't look amazing. We've got now I want to put a material and all that stuff. So the way you do that, you go in the manage. Actually, no. Get select, click on the landscapes. And you see that here in the properties, there's a landscape material. You can just click that, search for grass, select it. Okay, now we have grass. So I won't show you the paint process because it requires a setup in the material. But if you did have the setup, here's where you could choose which layer you're painting. paint on, and add rocks. So that's the very, very basics landscape. You see that in the top here, we have this red message that's telling us that lighting needs to be rebuilt. And that's because every time we add new objects or move existing objects, our static lighting that we've pre-calculated a few steps ago is now not up to date anymore, right? Because remember, it's been calculated with everything being in a certain position. Now we've changed that, so it's kind of broken. So we need to rebuild that. And you see that when I rebuild, things will look much different. It's also going to take a little bit. So you see swarm, this thing. It's definitely. You guys all good on the landscape? Not having any problem? Yeah, Reese, I actually don't know if you can unfill. You might have to. Okay, so lighting. So in your world outliner, if you search for landscape, right, you might just have to delete everything that's called landscape. Yeah, that was not the brightest idea. Delete everything that's called landscape and see if that removes it. Otherwise, if you haven't saved yet, just reopen your level. All right. So yeah, that's it. Now we have a basic terrain. Looks like crap, but not an artist. There you go. My floor is pretty shiny. And you can see what I was talking about with the global illumination. You can see how the blue really bleeds out on the reflections are actually picking up part of the terrain as well. Some of the green is bouncing on the walls. So that's one of the big advantage of the static lighting. All that nice bleeding of colors. Is there any question before I move on? Okay, move on then. So the next part of the landscape series is foliage. Foliage is kind of goes hand in hand with landscape because foliage allows you to paint not only on a landscape, you can actually paint on any kind of mesh. You could paint on your house if you want. But it allows you to paint instances of actors. And 99% of the time, it's going to be used for like trees, grass, any kind of foliage. But the reason it's useful is that it can be used with anything. Like you can see on the screenshot, they've actually used it for rocks as well. And there's two big advantages of doing it that way. One is that it's easier to place because you're just painting. And when you're painting, you can set rules like, objects should match the orientation of the slope of the terrain and stuff like that. So it makes it way easier to edit. But also, it's automatically optimized for you. What that means is that it's instantiating all these meshes. Without getting too technical, what that means is that when you place objects manually, when you drag and drop them from the content browser, it creates one instance every time, right? So if I was to manually place all these rocks, I would go like 1 rock, 2 rocks. And then I would have 15 instances of that rock, which means when I run the game, it will cost 15 times the cost of a rock, right? Because the GPU has to draw every rock one by one. But the instance system, the foliage, basically make it cost like 1 instance because all these rocks are instantiated as 1 instance. So it's basically way cheaper. Watery landscapes, no, they're not part of this lecture. If you mean having water that you can like swim in or stuff like that, it's not actually a landscape technically. Water, like you can have a material on the landscape that looks wet. That's not. If you want water like a lake, it's a completely different feature. It's a completely different way to do it. There's actually quite a lot of different ways to do water. It's a bit complicated, so no, it's not going to be part of this lecture. There are some tutorials out there, but be careful because there's quite a lot of them that are not great. The way they show is probably very expensive. Maybe watch out. Which ones?
Hey,
Anyway, back to foliage. Yep.
just a question. When I created my landscape, it says the lighting needs to be rebuilt.
Yeah.
However, when I do that, it says there's over 10,000 objects that need to be rebuilt. I'm going to just place one landscape in.
What? Where do you see that there's 10,000 objects?
It says in the top left, below perspective, it says lighting needs to be rebuilt.
Oh, and that's like a lot of objects.
Yeah.
It's possible because I think 10,000 is a lot, but
It's stuck at 10,024, but I have looked along, so it's over 10,000.
yeah, I'm not sure. Maybe share your screen and I can take a
Yeah. Because right now I'm just rebuilding the lighting to see if that'll fix it. The only problem is when I do that, let's just say it takes about 10 years to do it. So the logs actually say 10,000, but it's saying 1,024 up here. For example, like preview, I know that's when lighting's all cooked in. It's been on 0% for the last 3 minutes now.
yeah, building the lights is pretty heavy. It looks like your landscape is pretty big as well. I don't know if you use the default settings or not.
Oh no, I think I know why, because I kind of filled the world when I made it. That could be it.
Yeah, if you use different settings, it might be bigger and then take more time. What you can do to reduce the time is use something called a light mass importance volume.
Yeah,
If you look at my
am using
screen
that.
real quick, the volumes.
Yeah, I am
light
using
mass.
that on. I'm using that on my actual, like, playable area.
Okay, you have that already. Yeah, if you have that already, then not much you can. I would look into maybe the size of your landscape or the settings.
Yeah, I'll have a look at that. I'm just
Yeah.
wondering why it was taking forever.
It depends. It really depends on your computer. This one, it's really extremely CPU intensive.
Oh no, because then if that's the case, my CPU should be fine.
Yeah, I don't know, man. Sorry.
Yeah. Oh, never mind. It's building properly now. Never mind. All right.
Yeah, all right. I move on. Yeah, so back to foliage. It kind of works the same as the painting on landscape. So you switch to foliage mode here, the little leaf icon. You have to set up the foliage first. You have to tell the foliage what you want to paint, right? Because we're painting meshes. So, in your content browser, you can choose a mesh, drag and drop it in that section here. That's automatically going to create foliage type for you. And once you've done that, you can just left click to paint, shift left click to erase. The foliage automatically aligns with the slope of the landscape. That's more or less it. When you click on the landscape, on the foliage itself, it's a bunch of settings you can play with, like you can add an offset vertically, you can have a random pitch, you can, it's not in here, but there's something called a scale. You can put a random scale so that it will be the same size, and things like that. So yeah, let's try it. Let's go in game, and then we're gonna create a new foliage type. We're gonna put a bush in there. We're gonna start painting around with that. So once again, go to the foliage tab here, or Shift 4, right? And then we get this window. You can see that right now we don't have any foliage set up. So what you can do is, in your content browser here, you click on content, and then you can search. Just search for bush. And you see there's a SM bush. That's our bush mesh. I'm just gonna drag and drop it here. And now you see that it's created a type for us. Cool. So if I click on that, and now you see I've got this little brush, I can just start painting around. adding a crap load of bushes everywhere. So even though I mentioned this is cheaper putting them manually, you still have to be careful not to put like millions and millions. Here it's telling me right now I have 2,000 of them, which sounds like a lot, but this is a game for PC. Yeah, so I'm painting here. You can see it's pretty dense. So I'm just gonna undo that and show you real quick what kind of setting you play with. So if you click on that here, I have a really small screen. If you go under the placement category, you can start playing with a bunch of stuff. So you can align to normal and set maximum angle if you want to. That's all fine. But if you scroll down a little bit more, yeah, right here. So sorry, in the painting category, you can change the density to be a bit less because remember when we painted there was quite a lot of them. So I'd like a bit less. I'm probably gonna go to like 10. And if you want, you can set minimum distance between two instances. So let's say I want at least 50 centimeter between each bush. So now when I paint, you can see that they're way more spaced. Right? You can also change the scaling. So right now they're all scaled the same. They all have the same size. But I can put a range here from let's say 0.75 to like 2. And now they're all going to be randomly scaled, be smaller or bigger. This way it looks a little bit more natural. So and these are the kind of options you can play with. You can change a lot of stuff here. So if you have time, experiment and see what you can come up with. So there you go. Now we have little bushes. Is there any question about foliage? Might move. Next session is about audio. So sound is quite often something that's overlooked, especially in students' production. We often see that being left for the end of the project, and then people don't worry about it until it's too late. It's actually something you have to think about pretty early on. It requires a lot of preparation. The setup is pretty easy. It still has to be done, especially if you're making your own kind of features, you're coding your own gameplay. You're gonna have to take sound into it. Yes, Stefan, you can turn on the collision. If you've already painted them, I think it's too late. But before you paint them, here somewhere. See under here, there's a collision preset. If you change the no collision to block all, then you will have collision on your rocks. But you have to do that before you paint. The ones that you've already painted, I think it's too late. One thing you can do is, you see here, there's this little arrow that says select. You can either select instances one by one, or you can do select all, right? And once they're selected, actually change them. Might not be, but you could delete them and start painting. But anyway, that's how you change the collisions here. Collision presets, set it to block all. All right, so yeah, back to audio. We're gonna be looking at the two major type of audio kind of assets. We got sound waves, which is basically the raw audio format, like when you just import a wave, that's what it is. And then sound cues, which is kind of like a container for sound, which allows us to put a bunch of like modifiers. So you can add audio modulation. You can add randomness. You can mix a few different sounds together to make one sound. Things like that. Yes, Stefan, it probably means your rock doesn't have a collider. We're gonna look at how to do that in the next few sections. So just wait for that and I'll show you. So yeah, audio. It's pretty straightforward. You can get an audio file either by importing WAV file. I think it also supports OGG format and stuff like that. But usually a WAV file is better. You can use an existing one. To edit it, you can, if you just double click on the sound, you see the properties here, and it allows you to set the volume, the pitch, things like that. Don't worry too much about what that means for now. Just know that if you need to change it, it's in here. Just double click the sound. To place an audio file, you basically once again just drag and drop it in the viewport, and that's going to create what's called an ambient sound actor for you. And the one last property that is good to know is the attenuation. What attenuation means is that in the world, it has a radius. It actually has two radiuses, radii, whatever. It's two big spheres. The full one is the inner radius. This is where you're going to have full volume. And then the second one is the fall-off distance, which means between the is where the fade is going to start. So the further away you go from inner radius, the lower the volume. Right? So this is to kind of simulate sounds fading away as you go further. So you can set these either in the sound queue. We're gonna look at that a little bit in a few seconds, or you per instance, like per object in the world, by clicking the override attenuation and changing the setting. So now for some a bit of advanced controls. It's an object type called sound cues. Sound cues, as you can see here, looks a bit similar to the material editor, right? Because once again, it's a little bit of script, a little bit of code, but these guys have a few nodes connected to each other. And what that allows you to do is to add effects, mixes, stuff like that to a sound, process it. Keep in mind, 99% of the time, it is better to use a sound cue instead of a sound wave to use in a level or in your code. Remember, sound wave is like the raw sound format that you've just imported. It's not processed. And sound cue is the same. It references the sound wave that you've imported, but it adds a bunch of process on top of it. So most of the time, you want to use a sound cue, not a sound wave. To create a sound cue, you just right-click on the sound wave, and then select create cue option. It's automatically going to create one that's already set up. Yeah, once again, the flow is the same as the material thing. There's this output node right where you need to connect whatever you're doing. And then you can see on the left, there are wave sounds, wave player, that you can use and connect to a bunch of effects, like modulator, mixer, stuff like that. So let's try that, see what we can do with sound. Oh, sorry, wrong section. Yeah, there's actually way more to sound than this, but we won't really have time. And I just want to show you guys the basics. But if you're interested in sound, look at the link over here. And there's things like sound classes and sound mixes that are really important, especially when you make a full game. You know, for example, in some games, when a character is talking, when there's a dialogue, they automatically lower the volume of every other sound in the game, like gunshots and stuff like that, so that you can hear what the character is talking. And in Unreal, that's done to sound classes and sound mixes, because you're gonna have your dialogue as dialogue class, and your gunshot as gunshot class. And you can make a mix that says whenever a dialogue is played, I want the gunshot volume to be 0. This kind of stuff. And a few other things in there that are pretty useful. So if you're interested, so yeah, now let's try it. Let's try to add a bit of ambient sound to our landscape. We're gonna try and place existing one, but we're also gonna try and create our own sound cue, mix our own audio in, and see if we can create a bit of randomization. So let's try that real quick. So first, to place existing ones, if you look in the starter content, and remember to clear your filter. Starter content in the audio folder, there's a few sounds you can use. Remember, it's better to use a cue file rather than wave file, right? So I'm like, okay, do I want this one? Oh, you probably cannot hear the sound from the cast, but I'm gonna put this one called starter background cue. Basically sounds like wind, birds. So you see that when I drag and drop it, when you drag and drop the cue somewhere, it creates that little actor here that looks like a speaker. Oh, yeah. Be careful if you're still in foliage mode. You cannot select any objects. So be careful to go back to place mode when you drag and drop something. Otherwise, you won't be able to select. So now I can select this object, and you can see that it's got a little loudspeaker icon. And it's gonna be playing a sound. I don't think you can hear the sound on my stream. It's not working. But right now, it's playing a sound of like birds and wave, wind and stuff. If I play right now, I can definitely hear like wind, birds. So if you're following along, hit the play button, and you should be hearing birds. Now, what I want to try and do is make our own sound cue, just so we have a concept of what sound cue is. So I'm going to create a new folder here, sounds. Create a new sound cue, right? And like SC. Forest. Cool. Yeah, Finlay, check if you haven't deleted the player start by accident. It should be in your world outliner if you search for player start, and see if it's not inside geometry or something, and move it around so it's sitting on the floor. Anyway, I've created that sound cue, and now if I double click and open it, all I have is that output, nothing connected to it. So I need to add an actual sound to it. So what I can do is you can see on the right palette, I have a wave player. Just drag and drop that. Still set to none, but in here in the sound wave property, I can for any kind of sound that I want. And, I know there's some like birds stuff somewhere, so I'm just gonna look for bird. Yeah, add some birds, and then, by the way, you can duplicate nodes by either right-clicking and selecting duplicate, or you can duplicate that, change birds to let's say wind. Yeah, wind, and duplicate again. And actually, on the other wind. The thing now, I can only connect one of them, but I want all of them to play. So for that, we need to use a node called mixer. If you look in here, there's a mixer node. Just drag and drop it here. So I go 1, 2, there's no more. Or you can add an input by clicking the add input. You can have as many as you want. So like that. Now I can finally connect output to the final. So what a mixer does is that basically just plays. bunch of sounds.
Just a question.
Yeah.
Is it possible to lower the volume of one specific node by leaving others at the same volume?
So I'm not sure what you mean.
So suppose you want birds at max volume, but you want window 5 at a lower volume. Is it possible to change the volume of one of the nodes?
Yeah. I'm actually not an expert in sound, but I'm pretty sure there's something.
Yes,
Yeah, I think it's modulator. So you connect modulator here, back there, 30 million max each and volume.
Sweet, thank you.
So yeah, we're mixing these three sounds. Sweet. And I'm gonna save that. There's one thing. There's one thing I want to do first is show you guys how to do attenuation. So remember from the slide, attenuation is that kind of like radius that will make it kind of lower volume as we go away from it. So this is done. You can do it directly in the sound by checking that override attenuation. Once you do that, a bunch of properties. One we want the attenuation distance, and probably the default setting of mine. So save that. Now I'm going to delete the previous sound that I had. I'm going to put the sound that I've just made. You can see now that this sound is different. It has a radius, a small radius, and a bigger radius. So that's our attenuation.
I think the radius is because when you at the actual sound cue, basically everything is grayed out.
Yeah, so that's because I have to first tick the box that says override. Once you tick that on, just go back up, you see that some setting will tick. So then you save that basically you see the radius.
It's working now. Thank you.
Yeah. And so yeah, that shows you basically that when you're inside the first radius, this is going to be full. As you go away, it's going to be lower and lower, just to simulate the sound. So if I play, oh, I forgot you guys don't have. Anyway, trust me on that one. It's full volume now, and then as I go away, you can hear it less and less and less, and now it's gone. So if you're following along, hit play and see how, as like you go further away, you're gonna hear less of it. Is it working for everyone? Lyra, that's a bit of an advanced setup. I'd say it's more on like the art side. Something artists usually. Like animation of trees is something you would do material, and it's a bit of an advanced concept for material. Usually artists will do that. Player movement. Yes, we could do a workshop on that, though most of the templates when you create a new project will give you all of that for free, at least the basics of it. So I recommend you start with that. And you can actually, once you've created the template, you can open up the character. You can see how they set it up. That's actually a good example of how to play with the character, at least the right. What you mean by smooth? You mean like animating the object movements? We are going to look at sequence at the end of this lecture, which might help you with that. Okay. Just gonna check how much slides I've got left. So we're running a bit out of time. You guys doing all right? Do you need a break? It's almost the end actually. of the
We
lecture.
should be fine. I
Yes.
mean, how many more slides do we got?
Yeah, that's quite a lot. So I don't know if we're going to be able to.
I mean, because we can split this lecture into 2 workshops or something, if that'll work.
Yes, that's true, but next week is actually another important one. That's all right. I might skip 1 or 2 that are not too important, just so we can see the important ones. So bear with me, we're almost there. If you do need an urgent break, let me know. But I'd like to try and go until 12:30. That's all right with everyone? Yeah.
Yeah, sounds good.
Yep.
Yeah, so I might go a bit quicker. If you do have a problem, let me know, or like I can always DM. So the next part is rendering features. For this one, I'm really going to go quickly just to show you what's available, not really how to use it, because this is totally going to be honest, but you guys should actually know. So yeah, few features is like the first one is fog, it's straightforward. A few lighting features, so to simulate what we call God rays, like that, and post-process, which is basically once the game has gone through the render process, once the game has rendered all the meshes and material, and that's complete, then you can add a bunch of effects on top of the render. You can think about it as like, when you go to Photoshop and you start adjusting the saturation, brightness, or you start tweaking the colors and levels. It's kind of the same, but real time on top of game render. Yeah, so when it comes to fog, you have 3 main types of fogs. First one called exponential height fog. Sorry, Jordan, I'll send the files after the lecture. So yeah, exponential height fog, which is the one in this screenshot over here. That's the cheapest and most common fog. It basically creates a fog from a height, from a specific height, and then gradients down from that height, right? So you can think of it as like a vertical gradient. And you see it here's one of the most common use for that fog is to kind of simulate, lower fog in a valley kind of morning. Because really it's vertical, right? If we made it higher, you wouldn't really tell the volume because it's just a vertical gradient. But it's the cheapest, and you can get some pretty decent environment out of it. So it's pretty nice to use. The second one is volumetric fog. It's actually a setting on the exponential height fog that you can turn on and off. But it's a very expensive fog because the fog now actually becomes a volume, which means it has awareness of 3D and occlusion, which means that, as you can see on the screenshot, the fog can either exist or not depending on where the light is coming from. The light is blocked by an object. See fog, which will create this kind of like God rays from the sun. But this is pretty expensive, so bear in mind. And the last type of fog is the atmospheric fog, which can be used combined with a normal exponential height fog. What the atmospheric fog does is that it uses the setup you have in the default map, in that sky box they have, and the directional light to simulate the color of the lighting from the atmosphere. So if your sun is a bit lower in the sky, then your fog will become a bit more orangey, right? So the atmospheric fog takes care of that. It changes the sky color based on the rotation of your direction. Few lighting features. The first one is called light shaft. You can set that up on your directional light property. It's just a section, just one box you toggle. And you can see it looks a bit similar to volumetric fog, except that this is way cheaper. So if you ever want to do some effect like this, definitely go for the light shaft instead of going for volumetric, because it gives you almost the same result. The only kind of gotcha is that these rays will only appear if the light is in the camera view. If basically right now I was to look away, then the rays will disappear. That's because of the way it's calculated. That's what makes it cheap. Sorry. The other one is light profiles. That's something that artists really like to do because it helps shape the light, especially spotlights. You can see how here it's getting like a multiple step kind of gradient edge, and here it's kind of giving that kind of arrow shape here, right? So artists really like to use that, like funky shapes to the light and make it realistic. These cannot be animated, right? So this works on a static light, also works on dynamic light, but you cannot animate that thing. Let's say you wanted to animate the shape to bigger, smaller, or what, you can, because of the way it's calculated. It's actually a specific file format that you need to import because it's based on some industry standard from the movie industry. Anyway, it's a specific file format. Keep that in mind. The next one is called light functions, and you're probably going to see artists use that quite a lot. Light functions allow you to put a material on a light. Now, materials, I've only shown you the basics, but material, because it's shader code based, can do quite a lot of stuff. You can animate things, you can give volume, you can have patterns, they can move. So you see in that screenshot, they've actually shaped the light to have all these like patterns and can be animated. Keep in mind though that this only works on dynamic light. So if you see that in a level, this probably means the light is dynamic. Good indication that it's probably going to be expensive. So yeah, the next part is post-process. So post-process, like explaining quickly, is, once your game has rendered, so all the meshes have been rendered, the material has been rendered, even the lighting has been rendered, there's a final output, which, if you want to be technical, is called the G buffer. And that's basically your final output of the game. I mean, final, quote, quote. That's, the render, the output. You can still get that render, and you can still apply a bunch of effects on top of it. Just like you would Photoshop, add a bunch of layers, effects, and you can play with the saturation, the brightness, stuff like that. Except that you can do a lot more with post-processing. A few examples, look at the screenshot at the top. You can play with the camera settings. So, you can play with the lens aperture, the ISO, the speed of the lens, which kind of gives you like blurriness up close. And looks like it's in focus over here, right? So focus distance, all that stuff. You can change that in the post-process. You can also change the overall, saturation, brightness, tint of the picture, like they've done in here. They've basically made everything not saturated, so it looks very gray. What else is there? Auto exposure is the one I've shown you around the beginning of this lecture, so that the brightness adaptation is quicker. And there's also, stuff like lens flare or reflections and stuff like that. So one of the most powerful part of post-process is post-process material, which once again lets you assign a material to your post-process. And once again, because a material is shader code, you can do quite a lot of things. Look at these screenshots here. These are all the same scene. These are all the same render, like the same output that's been modified with different post-process materials. So you can see that you can achieve quite a lot of different looks. And these are all real time. You could play, this would work real time around that look. Because it's not just 2D, right? Sure, we're adding a process effect on top of the render, but it's still your 3D world. So it's pretty powerful. you can do quite a lot of it. You see that range of different visuals you get is pretty wide. So I don't know if we actually have time to try that. All right, I might show you like real quick what the post-process can do. Hide fog, lash shaft, post-process. Okay. So let's add a fog to our level. In the place mode here, you see there's a search classes box. Search for height. If you search for height, you see an exponential height fog. Just drag and drop that level, and already you'll see that it's become a bit foggy, but not quite like I was talking about. So let's see if we can replicate. If you go in the exponential height for the component here, crank the density all the way up, see that it becomes a bit stronger, and crank the fall off all the way up as well. It's better, but it's still not what I want, right? That's because one of the important concepts is that the fog gradient starts from the position of the fog actor. So if I was to move this up, you can see that now it becomes more dense because the fog gradient starts from here all the way there, right? That's one of the important things. So now if I lower it down, play with the settings, some doesn't look as good as I, but you can see that we've kind of created a fog that's only at the bottom part of our valley. If you play around with the settings, I'm sure you can much better than we just done. But I just wanted to show you the important settings are the density, the fall off, which is how long the gradient is going to be, like how smooth, and the height of your actor as well. So that's the height fog. Also going to add light shafts. So remember the light shaft comes from your directional light. The directional light is this icon with the sun arrow. If you can't find it, search in the world outliner for directional light. And you'll see that in the default level, they call it light source. That's just a name. But yeah, remember that when we turn on the light shaft, they're going to be coming from the location of it, from the direction of it. So we need to place it somewhere we can have some nice light shaft. And you'll see what I mean in a second. So if I go to the details, scroll down a bit, there's a light shaft category here. It's actually two different modes of light shaft, but I think the one you want is the light shaft. So turn that on. Right away, you can see that it's kind of blowing up everywhere. That's because, remember, the light shaft's coming from the sun, right? Because this actor here, its position doesn't matter, only its rotation, because this is meant to simulate the sun, right? So our sun is right there. You can see that if I come close to a wall, we're starting to have this kind of nice little light shaft. Default settings are pretty bad. Let's tweak that. You can lower the bloom scale a little bit to, I would say, 102, like that. This would be nicer. Actually, maybe not. Maybe play with the max brightness. Lower that down. And then the threshold can also help not having it trigger too early. So anyway, I'm not going to go into too much detail because it's probably for the artist to tweak. But you can see how like this easily gives us kind of nice God ray effect, and it's pretty cheap. You can actually change the color. This is how you set up light shaft. And then the last thing I want to show you quickly is the post process. The post process is, if you remember earlier, we've actually already added post process volume to our level, which is this box over here. If you can't find it in the world outliner, just search post-process, and it's going to be yeah. If you look at the details real quick, just if you go to lens category, we've already looked at exposure. There's quite a lot of other effects. I'm not going to go through all of them. Feel free to play around with that, and then usually see right away with it. Bloom is what you're seeing right now. It's like how everything becomes white when you look at bright parts of the screen. Exposure, we look at that. Most of these other ones are to simulate a real-world camera. So to have dirt on the lens, or here you can play with the aperture, stuff like that. Usually mostly stuff for artists, but it's good for you to wear sleeves if you need to. You can color grade here, completely change the color of the scene just with that. And that has nothing to do with the lighting. That's just an effect. So that's color grading. There's a bunch of effects to simulate old films. Mobile had their own kind of setting here because it made it a little cheaper. And here are a bit more advanced stuff. The important ones. Post-process material is what I was talking about. You can plug a material here. I'm not going to go into how to create one, but if you had one already, like asset, like this is where you. All the other things are to basically tweak some of the rendering features. So the ambient cube map, you see all these reflections here. These are made through a cube map. This is really bright. And I can actually tweak all of these, reduce the intensity. Oh, I didn't. Sorry, I can show you. But if an artist is talking to you about the cube map, how to tweak it, you can actually tweak the settings here. Ambient occlusion is again a bit of an advanced thing, so I'm not going to. But global illumination, we talked about it, or the light was bleeding onto other surface. You can actually override that here, change the color completely. All the bounce lighting, because remember the bounce lighting is stored in a texture, right? The light maps. So this basically kind of overrides the light maps tint, which I don't know, it's probably not a great thing, but you can always kind of like make your whole scene bounce lighting brighter just by doing it. Anyway, there's a bunch of other stuff. It's a bit advanced, so I'm not going to do much because your artist will. Yeah. Is there any question on rendering features?
Oh yeah, what's it called? Just I nearly forgot. How do you change the color of the directional light again? Like, how do you like make the light have like, sorry, the fog have a gray tinge, like not a gray, like orange tinge?
You're talking about the fog or the light?
Kind of both, because I kind of, for like what I want to do, I want to like try and make my map have like an orangish tinge to it, like the entire thing.
So the fog itself, you can change the color in the property here. You have a fog in scattering color, hide fog. So if you change that, you see that the fog changes color.
Okay.
Right. But that's kind of more to fake it. If you're using the default map template, actually what they do is they already have an atmospheric fog here, right? This is already set up. So what you could do is you could select your directional light.
Yep.
So select your directional light and play around with the rotation of directional light. Because remember, that sun you see in the sky is based on the rotation of that directional light, right? So if I play with the rotation and make it almost kind of like straight, like it's almost like sunset, right?
Yeah.
If I do that and then click on the sky, once you click on the sky in the property, there's a refresh material tick box. Click that. You see that now my sky has turned orange, right?
Okay.
So this affects two things. This affects the texture of the skybox. This affects the position of the sun here. This is also going to affect the color of the directional light, the color of the atmospheric fog, but it does not affect the color of your height fog, exponential height. That's something you need. Because usually the height fog is kind of like on top of everything else. It's just to add like a kind of like you can see how just by changing the rotation of the sun, I've kind of changed the whole map.
Yeah, I see.
So yeah, that's what you do.
Good.
It's actually right here. I'm going to skip particle effects, running out of time, and also because in 4.25, the current editor for particles, which is Cascade editor, which you can see here on the screen, is going to be slowly replaced by a whole new particle editor called Niagara, which is really powerful, really amazing particle editor, not just particle, all kind of crazy effects that you can drive through visual scripting, kind of similar to Blueprint. So kind of similar to the material editor. So that's going to be coming. It's already in 4.24, but it's kind of in beta. And I think in 4.25 it's going to be a little bit final. So it wouldn't make sense to teach you too much of all. But yeah, because it's already 12.12, I'm just going to skip that. If you ever need help with particles,
Yes.
the artist would probably know more. Yes?
Yeah, with the particle effects, is it already in effect in the beta version of 4.25, or is it not up yet?
Is what, Niagara?
Yeah.
So actually Niagara is already in 4.20.
4.25.
This one here, but you have to like activate it somewhere in the plugins because
Okay.
it's a beta thing. They don't expose beta things. But I think in 4.25,
Yeah, like
they're saying that they might release it as out of beta. So it might not be like official replacement yet, but probably in a few versions they're gonna start making this guy Cascade irrelevant little by little.
Thank you.
Yeah. So I'll just keep particles for now. But know that as a high-level concept, there is a particle system to make all kind of effects, from burst effect to trail effects, ribbons, beams. You can even have particles that are linked to an animation of a character, so like a trail on someone flying. So all kind of effects. They're pretty easy to edit. They're all based on little modules, emitters that you can easily tweak through. Just know that it exists. And then cinematics. Let's do it. Okay, I might have to skip cinematics. Well, I'm sorry. But if you need more info about cinematics, I'll give you like a high level. There's a tool called the sequencer editor that allows you to animate any actor, any camera, any characters. You can animate lights, you can animate materials, audio, you can make your own movie. It's similar to if you use Adobe Premiere or Final Cut or any kind of video editing software. It's the same concept. You can put clips, cameras, except it's all real time. So there's no render to do everything real time. So this is how you create cutscenes, cinematics, and you can animate a bunch of stuff. Yeah, sorry, I'm gonna skip that. If you want to know more about it, I'll send the slides and you can read that. There's also a bunch of links to the official documentation at the end. But if we see that a lot of you want to use that, I could do a workshop on it. It's pretty straightforward, but there's actually a lot of components to it. Yeah, we'll do that another. The important part, though, that I want to touch on is physics. So there's two aspects to physics. There's collision, and the actual physics simulation, gravity and friction. So they're two separate components, but they work together. Quite often, there's a lot of confusion about which one is which is why I think it's a bit important for us to. So let's look at that. The collision system. So any mesh in a level can collide with other actors in the level, right? So your character can collide with, that house that we, but also the projectiles from our guns will have to collide with enemies and the walls as well, right? But also collisions. Let's say my wall. I want my wall to be able to collide with an object that's simulating physics, as in, if you look at Skyrim, you all know the game Skyrim. You can pick up objects and then you can drop them and they fall onto the ground, right? Which means that my ground needs to have a collision, but my ground is not simulating per se because my ground doesn't have gravity, right? But when I pick up that object will be simulating and will be colliding with my ground. I'm hoping that makes sense, but it will make sense in a second. It's not decided yet which workshop we're going to do and when. I think we have to talk about it with Sama and decide on which ones are needed later. But if you do have stuff that you wanna hear about, then let us know. See what we can do. This is just taking way much time than I thought it. So yeah. So yeah, that's the collision system, right? So when an actor collides with another actor, that's called blocking, right? So it's basically the character is going towards the wall, and the wall will be blocking the character. That's what we call a collision, and that's called blocking. Something that's intersecting an actor without blocking it. So, for example, my character walks through a bush. It touches it, but the bush doesn't block the player, right? The player can go through. That's called overlap in Unreal language. So that's really important to remember. Try to remember that. Block is when you are colliding with something, you're being stopped by it. And overlapping is like you're intersecting with something. So to define the behavior of collisions for a mesh, you basically just need to go in the properties of that actor, and under the collision section, you can choose a collision preset here. And you can see there's a long list. And honestly, 80% of it you don't really need to care about. The important ones are block all, which basically means this actor will block everything. Overlap all, which means this actor will be intersecting with everything else, but at the same time will send a message to whoever intersected with that message. This is how we basically make trigger boxes, right? A trigger box is a cube that is been set to overlap all, so it's not going to like block anything. But when something intersects that trigger box, it will send a message to whoever intersected and say, hey, you just overlapped, right? Note that you do need to tick this box here, generate overlap events, for that event to be fired. This is kind of an optimization so that not everything starts sending messages everywhere. So things to remember: block all, overlap all, and that your tick box, trigger box to work. Yeah, that's kind of it. If you're interested about exactly what all of these means, these are preset categories that Epic made, but you can actually create your own if you want it. And you can see once you select one, there's going to be a little arrow presets, and it will tell you all the details. So what does it do? with the physics simulation here. Is the physics simulation enabled or not? And does it block or overlap any other kind of? So that's a bit advanced, but it's good to know if you're trying to debug something. So now to the second component, which is the actual physics simulation itself. Up until now, everything I've showed you is just collision, right? It means an object can block or intersect something. But it doesn't mean it's going to be simulating things like gravity, friction, mass, stuff like that, right? By default, nothing simulates physics. You have to tell it to. And the way you do that is by doing two things. First, you need to set it to movable. Remember our mobility type? It's not just for light. It also means a lot to actors. So if an actor is set to static, it will not be able to move. The editor is going to give you an error and go like, you're trying to move a static object. What the hell are you doing? So you have to set it to movable first. And then in the properties of that actor, under the physics category, you have to tick the simulate physics box. And as soon as you do that, that's what you need to do. As soon as you do that, that object will start behaving in the physics world, which means it will start falling because it will have gravity. It will start bouncing around on other objects because it has collision enabled, and all these kind of. Yeah, note. I can't remember who was asking me about rocks not colliding. This is basically the reason. It's probably because that rock did not have collider set up. So how collisions work is that, if let's say we have a mesh like that, and let's say this table was like a super high resolution, crazy mesh that someone made, and it's like 20 million triangle. It would be way too expensive to try and calculate physics with all these triangles, right? That would not be super smart. So what we do instead is we use a way lower resolution mesh to represent that actor. You can see here that table is actually just some kind of very basic box, right? Like look at the seat, it's basically a few faces. And that's important because that's where a lot of games lose a lot of their performance. They don't set up cheap colliders, and which means, when you have a lot of players, a lot of enemies that are shooting things around, and everything starts responding to physics, then there's a lot of calculation being made on like, oh, is my projectile touching this? If that object had 20 million triangles, that would be really expensive to calculate. So that's what we do. We need to set up a collider for basically all our meshes. Usually that's automatic. When you import a mesh in Unreal, will generate an automatic collision. Quite often, it's going to be a simple cube, simple box. For 90% of the objects, it's fine. Though sometimes some objects might require a bit complex collision, like that chair. You don't really want it to be a full cube because then, if you jump on it, you'll be floating in the air. So you can do a few things. You can either make your own collider mesh in another software like Maxon, but that takes time. That's annoying. So Unreal allows you to generate collision for a mesh. The static mesh editor. You can see here in this window, there's quite a few options, different options, from basically the cheapest at the top to the most expensive here at the bottom, auto-convex. It's still not extremely expensive, but like a sphere is always the cheapest. But basically here is where you generate the basic shape for your collider. So whoever was doing the rocks and wanting the player to collide with that, going to have to open the asset of the rock, go into the static mesh editor, and then generate a collision for that rock by using collision, probably a box. Add box simplified collision. Save that, and it should. And so yeah, let's try that. We have 5 minutes. Let's see if we can do a bit of physics. 5 minutes. So we're gonna try adding new meshes, having them collide, having them simulate physics, and then see what kind of weird stuff we can with that. Let's go. So I'm going to go in my house, and first thing I'm going to do is to select the floor and make sure that it's the collision settings are fine. Right. So I'm going to scroll down to collision, and it's set to default. So default is a bit misleading because it doesn't really tell you what default is. But default on a static mesh basically means block all. It's the same. You can see if I change it, there's no little yellow arrow, which means it's the same. So default block all doesn't matter for static mesh. But if you want to be 100% sure, just leave it to block all. So now this means that our floor will block and collide everything. I mean, it's already been doing that, right? You can see my character collides with that floor. It blocks it. So that's okay. It's pretty ugly. Yeah, and so what I'm going to do is I've got my staircase here. Staircase is a brush, and brush, I was saying earlier that brushes are usually only used for prototyping. You want to quickly make some shapes and stuff. And eventually, when we go into production and make the game for real, we usually convert or replace all this with actual static mesh because it's more efficient and it's better for collision, and it's better for artists. Artists will not want to do this kind of simple shape. But you can still set the collision of brush property. So if you select it, you still have to do that select all faces. That's really nice. So remember, you do Shift B, select all the faces. And then if you go in the settings, on the brush settings here, there's a solidity menu. You select solid, which I believe is the default. It means it's going to be colliding with it. And it was already colliding because otherwise we would not have been able to do the stairs, right? So that's all good. Everything's set to collide. Now what I want to do is add a physics option. How do I do that? Well, I can simply add any kind of basic mesh. I'm going to use the basic sphere mesh from the basic menu. So what that does is that adds a basic sphere mesh. But if you look in the settings, it's static, right? Remember, we need to set it to movable for it to be able to. Also, if we want it to simulate the physics, we need to tell it. So I'm going to, in the physics category, I'm going to tick the simulate physics box. And you can see that enable gravity is already on, right? So now, if I move this up, let's say I'm going to be smart and put the stairs, right? Now I play from here, it should fall and roll down the stairs, right? So you can see that all it took is one little tick box for that object to be included in the physics simulation world. So now that object has a mass, it has a weight, it has friction, it has gravity, so it's going to start responding to everything. You can see that the character actually has also been set up to respond to physics simulation because it's pushing that actor, right? So that's already set up in the third-person template. So that, that's kind of your basic example. It's like a little.
Just a question: how do you change the actual weight of objects? So if you want to have some inertia.
Yeah. So the weight is usually automatically calculated for you. You'll notice that by default, it's a bit ridiculous. So if you click on the properties, go in details, physics, there's a mass here. It says mass in kilo, 100 kilo. And that's quite a lot for a tiny ball like this. But you have to keep in mind that it's using something called physics material.
Okay.
I don't have time to show you, unfortunately, but physics material, think about it, is an asset you can create to tell the physics engine what kind of like object, what kind of material this object is. Is it like heavy metal, or is it more like light plastic or feather kind of material, right? And then once you set that up, this value will automatically change based on that. But for now, if you want to override it, you just click that box here, and then you can set the weight to whatever you want, 10 kilo. That's all you do.
Thank you.
You can see now it's moving actually a bit faster. It's only 10.
Yep.
Other things that could be important. In the physics, there's a bunch of settings to play with. Actually, the two important ones are these two ones, linear and angular damping. It's not exactly friction, but it's kind of like the force, the drag that over time gets applied to that object. What that means is that if I set this value higher to, let's say, 0.5, you see that the ball is not going to roll as much. You see how it stops much faster? Because it's got a way higher damping. So it's kind of like a resistance to the ground, right? So it's not really friction, but it's a bit similar. And you can do the same with, so linear means how it's gonna slow down when moving forward. Angular is how fast it's going to slow its rotation. So linear is the movement, angular is for the rotation. And that's kind of all we have time for. It's over. So yeah, that was it. Moving forward, yeah, on your free time, I'm gonna send these slides. Feel free to check all the links. There's quite a lot of links to the official documentation. It's a bit tough to give you an overview of everything because there's a lot of things in Unreal Engine to learn, and getting the basics is actually takes time. So feel free to look at all the links and experiment with the things we didn't have time to look at, like sequencer, or to make a cinematic. The particles, look at Cascade or Niagara. Here's an example here. If you guys use Twitter, I don't know if it's still cool to use Twitter these days, but make sure you follow this guy, Chris Murphy. He's an Unreal evangelist for Australia and New Zealand. And he's actually an awesome technical artist. He's making a lot of cool stuff and a lot of cool tutorials on Twitter. So follow that guy. But here's an example of what is shown recently, which is a particle system made in Niagara to kind of show what kind of advanced particle system you can do. Because, it's basically a particle system that lets you script everything with some kind of blueprint, any aspect of the particle system. So you can make it as complex as you want. Basically, what is created here is a particle that spawns plants, make them grow, and petals grow, and then they start fading. Basically, they grow and then they start flying off. Thing dies off. So this in a normal particle editor would have been pretty hard to make, but with Niagara, because script kind of aspect, it's much easier. That's kind of what's coming up. So, the video at the top, I think it's just to show you really kind of new things that happen these days. I don't know if you followed, but there's something called Megascan, Quixel Megascan. It's a company that makes a lot of very high resolution assets. It's actually like 3D scanned assets. And they've been bought by Epic, so which means all their assets are now free for everyone.
Yo, free.
Real. So what you see in this video, all these assets are free. You can download them, except I think that sci-fi stuff. But all the terrain, rocks, grass, all that stuff is free. You can download it.
Is it from the Epic Store or?
Yes. So you download Unreal, and then you go to
Marketplace, right?
Marketplace. Yeah. And if you look in the free section, there should be all that stuff.
But
you can also, recently they've also made the Quixel software free as well. So you can download the software, and if you log in with your Epic account, the software is actually free. So you can even create, there's something called Quixel Mixer, which allows you to create an equivalent of their materials, and they're way more complex. So you can make awesome stuff. So all that stuff here is free. That's a recent video they've made to kind of show what you can do. And that video is running real time, 60 frames per second in engine. So it's not just a render, it's a real time. So yeah, explore and experiment, see what you can do. One takeaway I'd like you guys to take this is that as a BSE student, you're gonna be within teams with artist and designer, and you're kind of gonna be the technical guy, right? So it's you're kind of gonna become the gatekeeper to technical quality of a project and efficient processes. And so that was kind of my goal with this lecture. I wanted to show you enough of, probably not in depth, but enough basic concepts so that you can know at least most things and how they work. Because it might be on you at some point to set up the processes, how artists are going to work. Like the example of material instances, and that's kind of like an important thing in a project. So yeah. So here's a bunch of links if you want to learn more. The official documentation is pretty well done. There's also that Unreal Learning website they've made a while ago. They've kind of made it recently, and it's become pretty good. There's actually quite a lot of courses. They don't advertise this website enough, but there's some really good courses in there, even for like C++. Like it's not just for content. There's a lot of programming content. And then on the official YouTube, there's actually some very interesting. They're very long. There's some very interesting live stream about specific topics as well. So some of you were asking about specific things. Definitely check some of these links. Will probably answer some of the things. So yeah, and be careful. One of the last points. Be careful when you look for tutorials. There's a lot of them on YouTube. 80% are crap. So please be careful, because a lot of them are like, this is my first ever time to do something, so I'm going to teach you how to do it. And then you look and they do it completely. Might be valid for them, their scenario, but in a production scenario, this would be a terrible way to approach it, because, for example, performance would be terrible, right? So it's a bit of a tough one, Hamish, because you can't really know until you watch it. You can't know until you actually know what's a good way to do it. But usually what I do, if I look for warning signs, like, hey, this is my first thing, or here's my first game, and I'm going to teach you this kind of stuff. What I tend to do is look for official things, like that's why I post the Unreal Engine YouTube link. Most of the things in there, they usually show you how to do it the way, and title like game framework or stuff like that, instead of how to make an amazing looking level. This is my first time. Kind of thing.
Yeah. Just a question, Chris.
Yeah.
Is there any specific places besides the official Unreal Engine that you would recommend for tutorials?
It depends for what kind of topic, I guess.
Okay, so it does depend.
Um,
And another question is, suppose we do have another workshop. If we do have one, I was just wondering if we could kind of center around kind of what students are asking for, like, for example, specific things, like, or something general, how something a student needs. For example, like, I don't have an example right now, but like, if a student wants to learn how to do something, and it can be taught to everyone, is it possible to have that in another like workshop lecture? Or
yeah, I think that is the plan. We
okay.
still have to talk about it with Sama on how exactly this is going to work, but I think what would be good is like see what you guys feel like you need most, because you do have an assignment that's coming where you need to make a whole game in Unreal, right? So I think
Yeah.
once you start working on it, you're going to start identifying topics where you need more in-depth information, right? And so I think it's once we start seeing that there's a big gap in a specific topic, we try and make a workshop out of it. Like Sama is saying in the text channel, next week we're going to be looking at Blueprint, right? Blueprint is the scripting language, the visual scripting language in Unreal, which allows you to extremely quickly make stuff like mechanic, logic. When you start learning code, for example, you're always spending hours trying to find out why it's not working, why it's not compiling. You know, where do I find the reference to this? What file do I need to include? Blah, blah, blah. And then, you know, only to find out 2 hours later that you forgot to put your bracket at the end. Right. Well, in Blueprint, you never have this problem because it's just a bunch of boxes that you link together. It's kind of like the material editor, but way more powerful. So next week we look at that, the basics, but also we look at specific mechanics, how to make specific stuff. Hopefully that would help you get started with a few of your projects.
Sweet. Yep. Thank you.
Yep. So yeah, that's about it. Are there any last questions? It was a pretty long lecture. That was actually 4 hours. I'm sorry we went a bit over time. I think I went a bit crazy on the content, that one. But I really wanted you guys to be able to see most aspects of the engine. Because what we're trying to push these days is to push for first years to have better knowledge. Better,
Yeah, no, that's fine. Yeah. I think most of the class would agree with me in saying that at least now we have like a general idea of what's going on and
that's right.
how Unreal works rather than some other engines.
Yeah, cool. Well, that's good. It's a good piece. I'll leave it to Sama now because you guys have to discuss submission. I've already taken so much time.
Sweet.
Thanks, guys.
Thank you.
Thank you.
Thanks, Chris. That was a long but a very sort of lecture. Thanks for that.
That's all right.
So, guys, for the submission, I can see that some of you have already submitted. And one thing that we get to know now that the web Dropbox is also open. So what we are going to do is, because I'm not sure that this is going to work for all of you because it's going to be done from the internet, we're going to do both. Okay, we're going to do the web Dropbox and we're going to do the link so that I feel safe that all your submissions have come through. Can you guys hear me?
Yeah, we can.
Yeah, okay.
Yes, we can.
Yeah. So I'm going to repost the submission link that I did post before because I feel like it might have gone. The web Dropbox is the way that we used to submit while being at school, Reese. The one that you have to type your username and password and then you go in and submit. This is much more formal because this is going to go directly to the school server, and this would make me feel more comfortable about it. This is what I'm gonna say right now. Don't worry. I'm gonna post the link that you guys can go for and try. So just give me 1 second. I'll post the link now. So we can submit through that. Hopefully that you guys are going to be able to access. Can anyone give it a go and let me know if you can access that?